6.3, this is part 2. We're continuing on with binomial random variables. We're going to talk about how to find the mean and standard deviation once we know we have a binomial distribution. And then, and those formulas are on the AP formula card. And then talk about 2 super important concepts, and I'll show you a little video and we'll do examples to illustrate them. So if X has a binomial distribution only, it's a common mistake to use these formulas when you don't know that's the case. So if X has a binomial distribution only, then the mean of X, written as mu sub X, is the number of trials times the probability. That's what you would get on average. And the standard deviation of X will be sigma sub X is square root of NP times 1 minus P. And we'll do an example with that in a second. So that's the first part. And then now we're going to talk about when sampling. When you're taking a sample, if you take a simple random sample of size n, so it's kind of like we've been doing trials. We've been saying we're going to do n trials, but it's similar to taking a sample of size n. It's sort of like you're picking these, like picking people are like it's like your trials. So when you're sampling, you take a simple random size of size n from a population, because that's where we're headed, especially in the next chapter on sampling distributions. From a population size big N, we'll just use to denote the size of the entire population we're sampling from. The thing is that if we meet this condition, we can use a binomial distribution to model it. So you can actually use binomial distribution, which means then we can use the formulas for it. If, and we've kind of wondered about this before, how do we know what sample size to take? We can use a binomial distribution if our sample size n is not more than 1/10 of the size of the population, then we can still use a binomial distribution. And the reason is, and we'll see in an example, the result, as long as your sample size isn't too big, the result will still be the same even if the trials are not independent. And we're going to do a calculation to show that in a second. So the lack of independence, even if you don't meet the I condition in bins, because you won't, because when you're taking a sample, you don't replace each one, right? You just take like a hand of cards out of a deck, or you take a group of people out of a sample, say of all students at Homestead High School. You can't replace them. So that affects the probability between trials is in quotes. So lack of independence doesn't affect your outcome. So we can just assume we're going to use the binomial setting. And then, so I'll show you that in just a second. And in fact, this is another thing about n. As the sample size, and I'll show you a video of this happening, as your sample size n gets larger, there's something else we can do. So it's like we don't want it too big. In some sense we don't want it too big, and in some sense we want it to be larger. So as the sample size n gets larger, so that this happens, n times p is greater than equal to 10. That's so that your number of successes is at least greater than equal to 10, and your number of failures is at least 10. If those two conditions are true on either end, then you can use our normal probability calculations. That's the end of this, and I will explain both of these in just a second. Use our regular, we can use normal CDF to do our calculations.